Alright, so this is the video for section 6.3b. This is after 6.3a, we broke these two up. So we're going to kind of put logarithms and their inverses together, okay? So if I just go and I find the inverse of both of these functions, remember, this is just y equals b to the x, okay? To find the inverse, I would switch the x and the y. And then I would solve for y. So to do this, I would write this in terms of log. So it'd be log base b of x equals y. Okay, so that would be the inverse of f of x. All right, now if I come over here and I find the inverse of log b of x, so this is y equals log b of x. Okay, so the first thing I need to do is switch the x and y, so x equals log b of y, and then I need to solve for y, and the only way I know how to do that is to write this as an exponential function. So this would be base b to the exponent of x equals y. Here's the inverse, okay? So notice these are inverses of each other, okay? So we're going to use that to help solve equations. All right, so before we do example 5, I want to talk about two different properties that we're going to use. Okay, so the first one is a number b to the power of log to the same base b of x. This is going to equal x. Okay, so to prove this, if I look at this as an exponential function, think a number to a power, okay, and I write it as a log, it would be log base b of x, right, is going to equal the power, which is log base b of x. Okay, so yes, these are in fact true, which means this is true. Okay, so one of the first ones is, once again, b to the power of log b to the x is going to equal x. Now this is only true when these b's are the same. Okay, another one that we will use is log base b of b to the x is equal to x. Okay, now to show that this is true, if I put this, write it as an exponential function, so I'd have base b to the power of x is going to equal b to the x. Yes, these are equal. Therefore, this holds true as well. So the other one is going to be log base b of b to the x is equal to x. Okay, now we're going to use these two properties to solve these problems here. All right, so let's look at A now. Okay, so we have 10 to the power of log 4. Okay, now remember, when there's no power written here, we can assume that it's 10 to the log 10 of 4. Okay, now if we use this rule right here, notice our base here, or our coefficient, and our base here are the same. So 10 to the log 10, b to the log b of x is just x, so this is just going to equal 4. Okay, over here we're going to use this one. Okay, we have to do a little bit of work, but not much. So log 5 of 25 to the x. Okay, so I want it to look like this. That's my goal. Well, notice right now, this and this are different, and I want them to be the same. Okay, but we could also write this as log base 5. Now 25 is just 5 squared. And then I could write this again, log 5 of 5 to the 2x. Now notice my bases, log b of b, right? This is going to equal 2x. I want you to go ahead and use A and B in those two properties, and I want you to pause this video, try to do C and D on your own, and then we'll go over them. All right, hopefully you've at least attempted these on your own. So if I look at this, this is 10 to the power of log, and remember when there's nothing there, it's implied as 10 to the 18. Now because our b's are the same here, 10 to the log 10, this is just 18. Okay, and if I look at this one, if I write this, I want it to look like this. Okay, so I could write this as log 4 to the, well, 16 can be written as 4 squared to the x. And then I could rewrite it again as log 4 of 4 to the 2x. Now, my b and my b, same as b and b here, this is just equal to 2x. All right, so let's look at example 6 now. Okay, I want to find the inverses. So remember, f of x is the same thing as y. Okay, so the first step of solving an inverse is I want to flip the x and y. So x equals 6 to the y. Okay, now I want to solve for y. So in order to solve when this is an exponential function, I have to use logarithms. So I want to write this equation right here as a log. So it'd be log base 6 of x equals to y, and look at that, it's already in terms of y, so this right here is my inverse. All right, if I look at b, remember this is my natural log, which is also the same thing as log base e. Okay, now part of an inverse, I want to switch the x and the y, and then I want to solve for y. All right, so when I have an e base here, I can take e to the power of x is going to equal e to the power of this whole thing, log base e of y plus 3. Okay, or if you don't like writing it as log base e, you could write e to the natural log of y plus 3. Same thing. Okay, now notice e to the log e, that's one of the ones we did, is just equal to this. Okay, so e to the x equals y plus 3. Those basically go away. And then to get y by itself, it'd just be e to the x minus 3 equals y. There is my inverse. All right, go ahead and try to do C and D on your own. Pause this video, try to do them on your own, and then I'll do them with you. All right, let's look at C. Hopefully you at least attempted it. So this is y equals 11 to the x. And to find the inverse, I'm going to switch my x and y. Okay, and now I'm going to write this as a log. So log base 11 of x equals the exponent, which is y. It's already in terms of y. There I go. Okay, now this one over here. I'm going to switch the x and y. Natural log of y plus 6. If you like to write this as log base e, that's fine. Especially at first, sometimes it helps. Some of you don't need to, some of you do. Okay, now, from here, anytime I do natural log, I think I want to go with the number e. So I can say e to the x equals e to the log e of y plus 6, or e to the natural log of y plus 6, that's fine too. And notice my e and my e, this is equal to y plus 6. Okay, to get y by itself, I subtract 6 from both sides. There's my inverse. All right, I highly encourage you to try these monitoring progress on your own. So pause this video, work through them, and then I will work them out, and then you can check yourself. All right, so this is what you should have gotten. So that's the top part. Here's the bottom part. All right, so when it comes to graphing logarithmic functions, it's very, very, very complicated, okay? So what we're really going to do is we're kind of cheat a little bit. We know how to graph exponential functions, and it's easier for us to plug in numbers to find the graph of an exponential function. So we're going to do that, but then we're going to use the fact that inverses are reflections over the y equals x-axis. Not x-axis, the line y equals x. Okay, and that we're also going to use that the domain of f of x becomes the range of f prime x, or f negative 1x, sorry. So the domain of f of x is the range of f of x's inverse, and the range of f of x is going to be the domain of its inverse. Okay, so let's do an example. All right, so here's log base 3 of x. Now it's hard to find numbers and plug them in. So we're going to do this. We're going to find the inverse of this. Okay, so the inverse of this, I would write this as y equals log 3 of x. I would then change the x and y. And then to find the inverse, I would use the exponential to solve for y. So it'd be 3 to the x equals y. Okay, so if I kind of chart 3 to the x equal y, make some x and y's. So I have x, y, let's do -1, 0, 1, 2, and 3. Okay, if I use these x's and plug it into this formula here, I would get 1/3, 1, 3, 9, and 3 to the third is 27. Okay, so if I graph this, right there, 0, 1, 1 goes to 3, 2 goes to 1, 2, 3, 4, 5, 6, 9, and I'm pretty much going straight up. So just like we know in exponential, I follow along right here, and then I cross, and then I go almost straight up. Okay, so this is the line 3 to the x equals y. Okay, now the inverse of this will be a reflection over y equals x, or what I like to do is I can make this chart again. And all I'm going to do is I'm going to flip my x and y. So at 1/3, if my x is 1/3, my y is -1. If my x is 1, my y is 0. If my x is 3, my y is 1. If my x is 9, my y is 2. And if my x is 27, I know I can't graph that out from here, it's 3. Okay, so then I can graph it. So -1, 1/3, -1, so it'd be like right here. 1, 0, which is right here. 3, 1, which is right there. 9, 2, which is right here. So notice, if I were to keep plotting and plotting and plotting, I would be going from here. Ooh, sorry. Let's try that again. Guys, sometimes writing on the slate is not an easy task. Alright, let's start from down here. Okay, it'll be straight up this line, not crossing it like I can't do here. Kind of like that. Sorry, that's really, really bad. But connect the dots, you get the idea. It should be like more like that, following those lines.